Okay, in this video, I'd like to do some linear programming using the table method. This should be very similar to the problem we did in class today. So that's our goal, making sure you understand the table method. By the way, this is what you do on Thursday. In today's homework, you should actually focus on just graphing them. But on Thursday, the entrance card, I'd like you to try the table method. And of course, we're going to work on this some more on Thursday. All right, so this is the problem from class. We wanted to maximize this function here, 50x plus 80y, subject to the constraints down here. So x plus 2y is less than or equal to 32, 3x plus 4y is less than or equal to 84, and my two variables, x and y, are going to be greater than 0. By the way, these two variables here, and if I don't mention it again, these are called my initial variables. Or that's what I'm going to call them, the initial variables. Okay? And so those are going to be important. And so in order to solve this problem, we want to use the table method. So it kind of goes as follows, and this is what I explained in class today. So these are just the steps relating to the graph we talked about in class. So our first step is that we need to change these inequalities here on the left into equations. Okay, and the way we're going to do this is by introducing something called the slack variables. And so the slack variables are things that would make them equal. So for example here, x plus 2y is less than or equal to 32, but maybe we need to add some number s to make sure that it's 32. And same thing here, we have this inequality, 3x plus 4y is less than or equal to 84, but maybe all we have to do is add this little slack variable t, and that's how we get it equal to 84. And so these will be, so the x and y, as I said here, are the initial variables, but the ones that we're interested in, the s and t, are called the slack variables. And so that's the first step that you'll do, is just to convert it. All right, next step, we're going to create this table. Notice that in this table, you do have the initial variables here, so these are the initial. So these are the initial variables. And then here you have the slack variables. And then here you'll have we want I'm going to call this the profit. This is what you want to maximize. So this is the profit, so to speak. Okay, so we make this table. You make sure you have all of them. Now the number of rows is going to depend. And so the number of rows, it depends on how many of the next thing you're going to do. But the idea is, and this is why I explained in class today, is that you're going to say, well, if x is 0, then I need y to be 0. Or if x is 0, then I need s to be 0. If x is 0, then I need t to be 0. And then x has been matched up. X is matched up with all of these. So then I move on to the next variable. And I say, well, y is already matched up with x, so let me make sure that I have a 0y, should go with 0s. A 0y should go with 0t. And then finally, I want to match up this s right here. So notice that this s is matched up with that x. This s is matched up with the y. I just need to make sure I have a 0 and a t. And the t is already matched up with all the other variables. So it's basically in twos. I want to make sure I have all the combinations of 2 zeros with each variable. And I'm explaining in class that there's this nice pattern where you have a straight line and a diagonal, a straight line and a diagonal, and so forth. Okay, so you want to create this. You want to make sure every variable is 0 with a partner from a different variable. And so what we try to do with this then is step 3. Now that we've done this, is we want to, that was step 3, to place the zeros strategically. The number of zeros is the same as the number of initial variables. Oh yes, this is important. So notice that I only have 2 initial variables, so I should only place 2 zeros. There are problems where you have 3 initial variables and you want to place 3 zeros. Those take much longer. We won't have to do that by hand, but it is possible to do something like that. All right, so what's our step 4? Well, we look at these zeros and we actually want to solve these equations here on the right. We want to plug these in to these two and be able to solve them. So for example, let's take this first row, x equals 0, y equals 0. So I'm going to say, well, if x equals 0 and y equals 0, then my two equations are s is equal to 32. Actually, let me go back there. Let me erase that. Let me try this again. It would actually be 0 plus 2 times 0 plus s is equal to 32. That's my first equation. And then the second equation is 3 times 0 plus 4 times 0 plus t is equal to 84. And notice that these two are gone, but I'm left with s is equal to 32 and t is equal to 84. Okay. Let me try a few more. And so I'm going to pinch this a little bit and zoom out and then maybe move away. And so let me now try, let's pick a different row. Let's pick, let's say this row right here. So you should do it for all of them. I'm just going to do a couple because I don't want this video to get too long. But in this row right here, what I want is I want y to be 0 and t to be 0. Y equals 0 and t to be equal 0. And so when I plug that in, my first equation is 2x plus s equals 32. Notice that I don't need the 2y because y is 0. And then my other equation is 3x is equal to 84. And notice the y is 0, so I don't need this. The t is 0, so I don't need that one. And so now I just go through the process of solving. I know that this equation here, x would be equal to 28. What I do is I divide both sides by 3. And I believe I get 28. And then when I plug that 28 into here, notice that that means that s is equal to 4. And so in this case, I would get x is 28 and s is equal to 4. And so you would go about filling this whole table. And so, for example, in this case right here, you would make sure you say x is 0 and s is 0. And you plug those into these equations and you solve for x and y. So I would suggest that you pause the video now and try this with the rest of them. And let's see if you get the answers, the same answers that I get. Okay, well, welcome back. I'm glad you tried it. Now here we go. This is what you should have gotten. This is what the table should look like after you plug in the zeros that you find in each row into each equation. So now if the initial, so that's these guys, and the slack variables, that's these two, are not negative, we plug in the values of the initial variables into the equation for p. What does that mean? Well, look at this first row. This is not, 0 is not negative, neither is 0, neither is 32 or 84. So that means what I'd like to do is plug in 0 and 0 into this p. So here what I would get is p would be equal to 50 times 0 plus 80 times 0. And this, of course, doesn't do much. It's equal to 0. Again, look at the next row. None of these are negative. None of these numbers here are negative. So I plug in 0 for x and 16 for y. And so I get 50 times 0 plus 80 times 16. And when I work this out, I actually get that this is 1280. Now I look at the next row, this is negative, so I'm not going to do anything for right now. Look at the next row, the t is negative, so I'm not going to do anything. But then here I come, none of these are negative. So I plug in 28 for x and 0 for y. And what I get is the following. I get 50 times 28 plus 80 times 0, and when I work this one out, I get 1400. And then I'm going to go ahead and do the last row also. Notice here I plug in 20 for x and 20 for y. None of these are negative, so I can go ahead and do this. And so I get 50 times 20 plus 80 times 6. And so in this case, I get 1480. And so you know the rest of it. You've seen it in class, but just to make sure, just for completeness, the rest of steps, on the ones that are negative, we aren't going to do anything. You don't do anything, just ignore those. So do not plug. So I just wanted to make sure I made that big. This should not be plugged in. We already know this is 0, this is 1280, this is 1400, and this is 1480, but the other two do not matter. So don't even worry about them. So as soon as you see negatives, just ignore them. Go on to the next ones. All right. And finally, if we actually want to solve this problem, the highest value of p, which is in this case is 1480, that would be your solution. And so your solution comes from this bottom row. And so the way you read this is you say if x is 20 and y is 6, we maximize the profit. And again, profit, it'll depend on the context. You maximize the profit at 1480. And so this is the same answer we got by graphing, but now you have a different way of getting the same answer. And then on Thursday, we'll go over another method to do this called the simplex method. All right, if you have any questions, send me an email. See you soon.